Hello, people. Oh, am I using the right microphone? Let's verify. Yep. 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 I'm gonna get some snacks on deck here. We're snacked up. Audio right channel. That's weird. Is this a stereo mic? I didn't think it was, but maybe it is. Maybe it's not plugged in all the way. It's a USB device. It is a USB device. This thing here that I thought was a volume level might be a pan. So I put it in the middle now. You only hear right? Does everybody only hear right? Maybe I just have to get a new microphone and this one's been super flaky. Everyone only hears right side. That's crazy. I mean, wait, okay, hold on. Looking here on the meter, left is happening. It's just happening less than right. This thing does not appear to be a pan. Maybe the microphone's just hosed. Advanced audio properties. Balance is an advanced property. So what if I just do it way, it's not doing anything. What if I do this? Okay, how's that? How's that, everybody? Does OBS just think every microphone is a stereo mic? Like what? That's pretty weird. That's like some Linux shit about having defaults that don't make sense for anybody. I should get 16 microphones and put them around the room, then you could hear me in surround sound. Okay, everybody. This is going to be such a good stream because I've got snacks and even professional water, right? I've got Propel Vitamin Boost Electrolyte Water Beverage. It's got electrolytes that plants crave. It's got more vitamins B, C, and E than regular Propel. And it tastes like strawberry raspberry, which is great. And it's got 10 calories for when you need actual energy. And then we've got core hydration to work out my abs. I'll have really good abs after drinking this. And then once I have good abs, I could eat the chocolate truffles that I got. They look like Christopher Elbow chocolate truffles, but the lady at the truffle store didn't know what that was. I assume she just works there. I've got a ton of these. They're all real good. I've got Chick-fil-A Polynesian sauce, but I don't think we'll be putting that on anything. That's just left over from the other day. I've got Hella Sun Chips. I've got so many. This is what happens after yesterday when I went out at 10 p.m. and nothing was open because it's Sunday in Knoxville. I've got beef jerky, really cheap, bad beef jerky. I've got fruit snacks for more fruit. Like, there will be no shortage of amazing things. And I've got a peppermint tea that I'm drinking right now. How many items large is my inventory? Good question. It's also a little bit warm in here. So let's talk about what to do. Off stream, I did some more attacking the back end, and I basically removed some of the stuff that this push pop situation was doing. But we still have a push pop situation in here. And so my goal for this stream is I want to get rid of this push pop situation and just have a much tighter inner loop here. So what I'm going to do, so all this pushing and popping and this frickin' thing, all they're doing is trying to put the length in bytes on the lexical block. And the lexical block is just some struct. That struct might not even be necessary long term, but it's just one that was added there, right? Or at least, okay, so this and this are just doing that. And then this thing here is what we had from a couple days ago, where we're just trying to do the same thing, but for statements, right? And so all of this, I think, can be removed if instead we just have a loop that says for every instruction, we have an array that's as many indices long as the number of instructions, but that's not that bad because we can reuse that array every time. So it just has to be as big as the longest procedure, right? One time. And then we just loop, we set the address, and then do the length, right? And that's it. And then after that loop is done and fills out that array, then for all the lexical blocks, we just index that array and poke the numbers. And then for all the statements, we just do that. And I think that should be, in principle, substantially faster code than this. It'll certainly be a lot less messy, and it'll feel more data-oriented than what's happening now. Are there any questions about this? Last stream you were watching was about Linux elf memory mapping and type variable names. Are we still working on that? We're still working on that general part of the compiler, but we've gone pretty far since that. We've done a lot of things to the back end. We've been attacking the back end. So oh, yeah, we should talk about the current timestamps. So, in fact, I should see what they are. So when I was at a coffee shop today, I removed this local symbols array. I mentioned that, I think, on the past couple of streams, but basically, in order to output symbols in the executable, there were loops that were copying them into these local symbol structs and then doing those local symbols into the output. And that intermediate step was completely unnecessary, so I got rid of it. In the process, I reduced code view data size substantially. So there was some kind of, either there was some kind of redundancy in the old thing, or I messed up and I'm not outputting enough, but it appears to work fine, so I think I am. So the data size for code view is now like 2/3 of what it was originally, which is great. And then this is the CodeView DT that I got running at the coffee shop, but you know, that's not running while streaming, so I should take some timings now and see where it's at, right? And it might not be noticeably lower than this. In fact, I think this honestly was a little bit of a low. I think when we did this one, which was on stream, I was getting some lucky measurements at first that were a little low, and the later ones were high, but who knows? This laptop is very flaky, so let's just make sure we're built, and then so 304, that's not great, but 298, 304, interesting. 29, these are very consistent now, but they're higher than what I would have expected. So, but that's even higher than this. So who knows? Like, comparing these is hard and weird when the laptop is this flaky, right? So I might just 286, 358. Like, I don't know, guys. I think we're at the point where this is fast enough that, like when we took 60 milliseconds, then plus or minus 8 milliseconds was not that much. It seemed stable. But now that we're around 30 milliseconds, plus or minus 8 milliseconds is like plus or minus 25%. And we're in the realm where it's just kind of hard to get measurements. So I'm just going to leave this non-streaming measurement. I don't know. We still want it to be as small as possible. We still want it to get smaller. It's really hard to compare stuff to millisecond precision without isolating it real good, but why? Why though? I think part of it is this laptop is garbage. Part of it is Windows just doesn't really help you with this at all. Are we using QPC? In this case, I believe so. Whoops. I accidentally saved a WSL2 file for some reason. RIP. RIP! I'm going to have a chocolate. Hey, when I ran it in Emacs, I got a good number. I wonder if this is faster than Windows console output. See, this is a lot more consistent for some reason. We'll call it I don't know. I think really this was 2.9 yesterday, and I could call it 2.8 today. This is extremely non-scientific. But the point being, our loop here is not very tight. So I want, like the pitch meeting producer, I want this loop to be tight, right? So that's what we're going to work on. And so what I need to do is go to that lexical block struct and say, oh, we have last instruction index. Let's make sure we set that. So we already have this information. So I think we can just use it. So here we go. I'm going to say here, wait, block indices we don't use anymore, right? Yeah, that's gone. Later, pal. All this will get to go away too. The stuff we did a couple days ago. Okay. If we're just going to say count is this, right? Let's give it a short name. If count is greater than or equal to, what do we call it? Instruction, location, scratch, instruction, address, scratch pad, right? Let's just say it's instruction addresses. Addresses dot resize count speed. We don't have to mem copy here. It's junk. Okay. So that instruction addresses is just going to be that. Now, in this loop, we're gonna say instruction addresses I equals C arrow length, right? And then we're gonna output machine code. And that's it. So let's make sure that compiles. So that's the added part. It doesn't compile, of course. Is that its output? All right. So we're not doing anything with this yet. And so one of the things we could do that's easy and simple is to do this thing that we used to have. Right, this was our debug statement locations. Actually, before we do this, let's get a baseline reading again. Shouldn't have broken, but we're going to just run the debugger on the Sokoban game and make sure that we can still use it and do things. How long have I been working on this? On the compiler? 6 years. All right. Bam. So we still have this. We have locals, right? This is all great. Awesome. So now I'm going to no check in this, and I'm going to say, instead of doing this complicated stuff, and well, let's leave the header stuff for a bit. So after this loop, we say for And then we'll say auto address equal info is statement debug info sub I, right? And then address is instruction address is sub I. So we're just reading it out of this thing that we wrote here, and then we're going to say, well, oh, not of I though, of info arrow first instruction, all right, and then statement info arrow offset in text section equals address. We can shrimp that down if we want, but that's all we're doing right there. So we'll see if that works. Do you have a second monitor while traveling? Nope, just the laptop screen, just what you see. Oh, and chat on the phone, yes. Okay. It's quite possible that it's broken, but hopefully not. Well, we got a breakpoint, that's good. And we're stepping. I don't know if I liked what I saw there, but no, it's fine. So this is a little bit weird, but I think it's a different mistake. It's like we're outputting this constant. The constant is getting the same address as this, and so the debugger is going there and like skipping these. Something like that. Actually, we can look at that. I'll make it separate though, because this is a smaller issue. We've got a bunch of smaller issues we could do too at this point. But anyway, this is very positive because it means this can go away. And then all this stuff, this jibber jabber that I did the other day, can all go away, right? I think, yeah. All that stuff. And then, I mean, even this can just go down here, there, and then this doesn't have to be two things. This could be that. So that is a lot less code than what that used to be, which is great. How is this tightening the loop? Because there are a lot more bytecode instructions than statements, right? Like, by definition, a statement, if it's doing anything interesting, is going to have multiple instructions. I actually don't know what the average is, but when we were stepping through yesterday, some statements had 3, some had 25, right? Like a procedure call that puts in a bunch of arguments and stuff, that's like one statement, but it's like 25 things, right? Now that said, we could elect to promote some of those arguments to statements if they're complicated. That's a choice that we have later when we get more sophisticated about this. So anyway, that has removed, so the main thing that we want to be doing in this loop is just these 2 lines, right? So there's these 3 other things that were happening, this, and the old version of this, right? So removing this one thing out of that loop is good, but it doesn't hit its stride until we get the other things out as well, which we're now about to attempt. So I'm going to do that now. Normally I would like check in here or something, but we're just going to go for it because that was so easy. We can always undo this and ungo for it if we want. So all this is going away, and the loop is now just that. And then down here, we're going to go bytecode lexical blocks.count. Lexical is bytecode lexical blocks sub I, and then we're going to go lexical arrow, what are they called? Lexical arrow offset within text section equals, let's just do like start equals instruction addresses arrow lexical first instruction index. We're just making sure it's within the range, right? Else, we might not need to be this complicated, but we're just going to do this, right? Oh, and then here, the reason I put this in another variable is because we might need this. This might be the very last block, right? Oh, actually, I think this would be better if it was last instruction index plus 1. So this stuff is all commented out, and then this stuff is that's literally all right. All right. So where was this one? Statement debug info. Interesting. All right. So we're going to put this here, and in bytecode builder, we're going to say +1, please 1. Wait, what? Yeah, that's disabled. Okay. We maybe shouldn't do the Don't do the lexical blocks unless debugging is enabled, question mark. Okay. So, so the reason I wanted to just do that is okay. So the end, if it's less than the end, then it's instruction addresses last, else output.length. Because we might be one past the end of this array, because the last element in this array is the last instruction. But in this case, we want the last instruction plus the length of the instruction, which is now, at this point, just how many things are there, right? Okay. End minus start. Okay. So that looks like a little more logic than we want, but it's less than what was here before, and it's not in the loop. So those are both good things. What is this DI type? That's not necessary. That's not necessary. All right. What happened? Can't you map to the assembly instructions directly? Then you have to write a different compiler for every backend. Or for every CPU. Like, being able to manipulate your own internal representation is pretty valuable. Why are we still running a Sokoban? All right, I could have woefully messed that up. So it makes me sad that our numbers are not, our CodeView DT numbers are not drastically lower. I was hoping for lower numbers there, but maybe at some point we could even start profiling again to see where all that, oh, there's still good low-hanging fruit to hit before we expect that to go down more. Okay, let's make sure that it works, which maybe it doesn't. Who knows? Is the IR lower level than the LLVM IR? Yeah, pretty much. It's much simpler, and it doesn't care what types pointers are. Doesn't really care what type anything is. Yes, 1 million lines per second is still the target. On a desktop machine on the Sokoban game, we're currently at around 120,000. So we're about a factor of 8 off that target currently. All right, so we are here. We're stepping down. Okay, I broke it for sure because yeah, we're not stepping in. Okay. So one thing I could do is just step through and verify, but I just want to make sure, like, did this push and pop do anything else, right? Um, it does use push instruction index and pop index, but I was thinking that those are just for this. Let's see. That's commented out. And so it's just used in LLVM and then this commented out code. So the LLVM we're not interfering with because we didn't change that function. Yeah, so I just want to see what it looks like. Oh, guys, we never set start at all. Bro. It's not, if you want to succeed in the games industry, set lexical arrow offset within text section. All right? That is my best advice that I have for the people out there. And look, we posted a much lower number as soon as I did that. Oh, wait. Except, lol. Compiler does have some threading, but not around most of the intensive work. It has threading around stuff that's already kind of fast, like parsing. Dang it. I swore that would have fixed it. Okay, everybody. We have to use the right back end here. Did I set up the +1 variables? Yeah. I believe I did. So start. End. That looks plausible. Wait, lexical first instruction index. I mean, that looks fine. Hmm. That's a little weird. Wait, hold on. We keep getting the same end address. Last is 31. Last is 41. Oh, guys, yeah, I was stupid. I put the wrong thing here. If you want to succeed in the games industry, put instruction addresses .count instead of bytecode arrow num lexical blocks .count or whatever it's called. Come on, put focus in the window. Dang it! Actually, you know what? Breakpoints are happening, but stepping into the function wasn't happening. All right. So we go from 1 to 19. Okay, so last time we had this problem, it was because the entry wasn't accounted for in the lexical block. And I think that's what's going on here. I think if I is equal to 0, then we want start to equal to that. Because that's what we had the other day as well. All right. I've got the sun chips on deck. Okay, what's gonna happen? Step. Dang it! Dang it, bro. So, why doesn't it like this? Wait, what? So this is two lexical blocks in a row that are the same? Like, why did that happen? Hmm. So it's just a block completely inside another block. That actually does make sense. It is fine. Do we use child cursor anywhere? Nope. Okay. I don't see anything obviously wrong with this, but I'm not sure how the input is different from the other thing. I could look at the old code to see if it did anything funny. Let's look at the code view, what it does with these. Goes over all the lexical blocks. We skip it if there's no members. We put a symbol for the offset within the text section. I don't know why we don't add the actual segment here. That's pretty weird. So this isn't the part. Where do we output? Wait, it's up here. What? Oh yeah, right here. So we see how big is it? Where is it in the section? We make a pointer to it. I don't know if there's some rule about code view sections. All right, I'm fat, but I'm going to have a sun chip. Once inside my stomach, the sun chip will radiate solar energy from the sun. And then the solar panels in my stomach will convert the solar energy to glucose, which I can then use to move around and do stuff. So this is one of those times when I have no idea what's wrong and nobody is giving me a hint what is wrong. I mean, I don't know. What I could do here's the 5-head maneuver. We're going to re-enable the old thing. Okay. And then here, wait, where is it? Where is it? Here we're going to assert. We're going to be assertive. I guarantee you this trips. But does it trip for a good reason? We'll find out. All right. So what that's doing is using the old code to compute the old values, which is why we leave it commented for times like this. And we compare them against the new values, and they won't match. Now that said, okay. So this start the thing that I did maybe wasn't the thing. Is this 58? Yeah. So we actually don't want to do this, which is fine. That was just me grasping at straws about what to do. It's faster not to. Oh, I dropped a sun chip. Sun chip down. A sequel to Black Hawk down. Why is it 1? That's what I want to know. Okay, this is all the commented out stuff. Okay, let's try a different workaround. Because I think this is what's weird. When we set it to this may just be an idiosyncrasy of when we're assigning those things. Because I think the instruction to generate the stack trace node may end up outside of this lexical block. Oh my gosh. We got through that without asserting. But not to the end. This looks like an empty block, but let's verify it. For these, I don't care if we match the old thing. So line 419 of command buffer. Looks frickin' empty to me, but that's a good point that you know what? If last is equal to first instruction index, we'll get 0 automatically. Let's do a thing here. This still might not match, but we're just going to assert that. And do that. I think that might still go off, but it might not go off for good reasons. So maybe the next thing to do is to switch back. This is a lexical block that got completely skipped. It's an empty block. Okay, so the old code just skipped it. This code should get length 0. Let's go ahead and have some faith here. So we're just going to say this and then this. Maybe that'll work better. So now we're redundantly computing it. We're still doing all that push pop stuff in the loop, but then we should be stomping over it down here. We'll see. Are we having programming language wars again? Don't feed the trolls. Dang it! Like, stepping is completely broken after that happens in Remedy. Maybe Visual Studio will do it better. Let's just try. Because this seems like weird behavior for Remedy. Step, 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 step. Didn't like it. I just skipped over it for some reason. But our ability to step is fine. It just won't go down. It won't go down into anything. So sort of the same as Remedy, except Remedy seems to get permanently confused for some reason. This is not going to help at all. What may help is Propel Vitamin Boost. If I can get the thing open. What if I can't get it open unless I've already had Propel Vitamin Boost? What then? Oh wow, it tastes super sugary. Okay, organic cane sugar is ingredient number 2. Yet it says 10 calories. I don't know, it tastes very sweet, dude. It's got electrolytes. is what plants crave. All right, this is going to do the same thing. Well, I can go back to the previous thing where we're asserting every time, and then just make sure we match the previous behavior number for number, even in cases that I don't feel like I should care about, right? I think that's the strat. We're just, every time this happens, okay, so what was the last one? It was about a block being empty. Let's look at that one again. That was weird. It was like the first instruction index was 0, which I wonder under what cases that happens. Oh, first instruction index 5. Last instruction index is 5. So with the push thing, I'm just going to put in extra wacky stuff. So we're going to get start. We're going to get first and last. If last is equal to first, start is equal to start equals -1. I'm going to put wacky on that because I feel like that is a reason, that is an unnecessary complication to remove. But first we want to duplicate the old behavior exactly in this new form. What is going on here? I could just say S32 down there. Output machine code 124884 minus what? Is it only on instruction 0? See, this is where it's like, oh, this old thing. This old thing had some weird behavior. Okay, we're down here. Length, lexical length in bytes -1, and start. Okay, so is this a last is equal to first? We'll put another wacky there. Another wacky jacky. Now watch, it's going to be I = 0 again. Wait. Oh, I did this in the wrong place, guys. Gotta do that there. Gotta do that there. Gotta do that there. I have end equals -1. Yeah, I meant that. Last, first. Yep. There's something weird about the 0th block in the old behavior. Because that's the last one popped, maybe, and the first one pushed. I don't know. I don't know. Now what? What are you giving me? 0, -1. End, start. 0, -1. Okay. We do that. I think that's more like what it was doing. I don't know, guys. I don't know. I don't care. You can see how sloppily I'm doing this. I literally don't care. I'm just trying to get to the end of this, and then we can figure out why these things matter. Dude, I don't fucking know. What? There's some other rule about why things would be skipped. It was that pop since things have no instructions. Okay, this one. So like, this is the thing that's causing us trouble. Oh no, this part. Maybe don't assert for empty blocks and see if anything else is weird. Yeah, it could be. Like I feel like we screen out empty blocks later. That's a good point. All right. So we could actually do the following. We could move all this stuff down to here. We could say, we can skip all these, in fact, because those were just empty block things, right? If last is not equal to first, we'll do this, right? Like, who cares? And by the way, we'll do this. Let's make this a coherent. Something like that. I feel a little bit less sharp right now, and I wonder if the water has not been pepping me enough. Whoops, that's the wrong thing to run. 029er. Stop. Stop. Wait, what? It's kind of not asserting. That leads me to believe that it's the handling of the empty blocks that is actually causing the difference, right? Which means it should be relatively trivial. All right, we're gonna get some Welch's fruit snacks because there's nothing like completely natural fruit to get your mind boosted, and fruit is their first ingredient. Ingredients: fruit puree, corn syrup, sugar, modified corn starch, gelatin, Concord grape juice from concentrate, citric acid, lactic acid. Yep, fruit's their first ingredient. No, to be first ingredient, you don't have to be 50%. You just have to be more than any other ingredient. So if you add a lot of ingredients that are different kinds of sugar, well, doesn't this look like fruit is the first ingredient right here? Doesn't it? Doesn't this look healthy? Mmm. Mmm, so fruity. Yeah, still broken. So it's something about the handling of empty blocks. Either A, there is some idiosyncrasy of empty blocks that CodeView wants to be that way and was undocumented in the original code, and we are not reproducing that. Or B, we're supposed to be filtering out empty blocks, and we're successfully doing that on the other thing, but not here. Where C, I don't know, I don't have a theory for C. Let's make sure it's either 0 or -1. In the code view situation, how do we skip lexical blocks? Oh, we skip it by, does it have no members? Well, la-di-da. Let's not skip it that way. Actually, we could skip either of these. I'm eating so much fruit. Mmm. Except when you say fruit, you mean fruit. So do I. I really mean fruit. Bro. Okay, one more experiment. We're going to leave this filtering out here. And then we're going to go back over here. And we're just not going to do any of this. And we'll see if that screws it up, right? Like maybe there's just something about empty blocks or something. I don't know. I don't frickin' know. Bro, that does screw it up. Okay, what if we don't eject those? So now if this fixes it, maybe it doesn't fix it, and then I screwed something else up, and that's good to know. But if this does fix it, then we can just break there and say, what are we outputting? And why? Oh my God, I'm having so much fruit. The hotel Wi-Fi kill switch happened before the stream. I waited till after. Can I share my inline assembly? There is no inline assembly. What are you talking about? You must be thinking of some other programming language. We would like to do inline assembly at some point. We do not currently have that. Okay, guys, I don't even know what's going on. I like super frickin' broke something. I give up. What did I do wrong? I don't really want to revert and do all of this again. This is very weird. Like what? Like we were fine for a bit. Let's try with Visual Studio for a second. Maybe we like permanently broke Remedy. Do I often use a diff tool to check what my changes are between versions of code? Sometimes, but only really when stuff goes wrong like this. And even now, I'm not that inclined to do that because I kind of know what the differences are. I mean, we could look, but yeah, it's broken too. I mean, we could do that. All right. So here, just a white space change now. Oh, wait, more. So this was our thing that we added, then commented out. Those are just things that were commented out that I cleaned up by deleting. So nothing there, hopefully. Here, I added, or I named this last instruction index +1. I mean, that could have broken something, I guess. So these are, okay. So at the start of the stream, we did our, this thing, and that was very successful and went very fast. So we could do that in isolation again, check it in, and then do the last instruction index +1 in isolation and check that in. And then we could go from there, but let's finish looking at these. Little sus, but hopefully not really. This is stuff that I just cleaned up. This is statement debug infos setup that we don't need. This is the new thing. This is all commented out. That's the new thing. I don't really see anything objectionable. All right, we're going to do one more Hail Mary pass before we revert and do some stuff over. And that is going to be full rebuild. Because we have had times, it's not likely that this will fix anything, but I have had times when like Visual Studio just decided that something was a different size or whatever because I kept changing it. Did you really expect everyone to understand the RGB color model to skip the floor in the elevator of the greenhouse? You don't need to know math to do that puzzle. No, math is not required. Everything that you need is visually there. I mean, if you do happen to know some color math, it wouldn't hurt, but it's not necessary. All right, so we're going to run this, and we're going to see that it makes no difference whatsoever and still doesn't work. How goes the Braid anniversary work? Pretty good. I might stream some programming on it in a day or two. There's some particle work that I want to do that might be interesting to stream. Yep, no difference whatsoever. So this is one of those things that should have been simple, but it's a complete disaster now. So I'm going to go here, right? We're going to revert it all. My favorite person in the games industry is Roberta Williams. All right, I'm gonna go again. We have this saved, so I can bring it back in piece by piece. First, let's just verify that having done that, we can actually debug again. Would I stream that work? I literally just said yes. I brought it up by saying I was thinking of streaming it. Would that be implementing some of the particle stuff I talked about on the blog a while back? I don't remember what I talked about on the blog. I should stream adding people to the beta. Maybe. Okay. Did we... Yeah, okay. Okay, if this doesn't work, then I have no idea what's going on. But I believe it will. I think the probability is that this will work. The probability is that this will work. If we ever get there, all right. Remedy like never loads with focus on this window. Hey, look, we could step in. Wow. Okay. Okay. So I'm going to do things in a different order this time. I'm going to go, I'm going to do the last instruction index +1 thing. Why? Because that's what I want to do. Okay, so this, but without the -1. All right. Again, this. Okay, that's already a difference. Oh, wait, no, wait, I'm visiting the same line. I was looking at it saying it doesn't have a -1. It's because I already put the +1 and you were about to paste the second +1, doofus. Same here. We get rid of the -1. All right. These are all disabled, 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 disabled. We maybe should just delete it at this point because it's pretty old code. But we're trying to minimize diffs right now in case something goes wrong. All right, we put the -1 there. And that's it. That's all the places that use it. It doesn't seem that hard. Yeah, I mean, the thing is when you have hundreds of people, I actually don't know how many people are in the chat, but when you have hundreds of people in the chat, the chances that like one person doesn't totally hear something because they're like doing something right now is very high. Right? It's just what happens. All right. Boom. Okay. Boom. We have polished off the tea. Step, step. Wait, we got the right focus. Hey, look, we could step. Okay, so I'm checking that in. Checking it in. Commit. Change index to index +1. Ship it. Okay, next part. We're going to do the what the hell are we going to do? We're going to do this current statement thinger. So we want to go here and we want to get this whole thing, right? And put that at the bottom here. Fruit at the bottom, yogurt. We do this instruction addresses here. All right, that goes here. We're gonna comment this out. We're gonna comment all this out. We're gonna delete this and this. What is even current start? And this. And we need to declare, oh wait, we need the part that checks the array size, this thing. And then we need array S32 instruction addresses. So this will probably work, right? And then the place that we went wrong was somewhere after that, where I went wrong. I don't mean to bring you into culpability here. Come on. Did I infinite loop it somehow? Really? What did I do this time? I don't understand. Let's see. It's probably something simple that I forgot. Wait, it finished there. What what's going on? Was that just my laptop getting hideously slow for no reason? I believe it. What is the culture regarding code reviews? Do you do lots of it? None. We do code reviews for newer, more junior people sometimes. But it's not really. It's not really like a rule, right? It's just more like it's a thing that we can do to be helpful to people who are trying to learn the code bases and stuff, right? Okay. Um, well, okay. Step, 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 step. Row. Really? Is it possible that at the start of the stream I did that wrong and then somehow was running the wrong back end or something? I don't think that's possible. Let's put our breakpoint somewhere better. Really? Well, we can do our other trick for this. I don't understand what the hell was going on, but we could certainly re-enable all these things, and then down here. Oh, guys. Oh, no, I did write instruction addresses. Okay. Well, here. I mean, what? Assert. Say what? Statement debug info is redefined. What? Oh, because I did that. Right. Okay. It was possible. I don't feel like it was possible. Okay, this is a thing about I being 0. I kind of don't get that. So if I is 0, we are here. And we say output dot length. All right. So why is that right? So we would do that here. Oh, wait, because current statement debug and it's okay, this whole thing. We did this explicitly. Really, did I mess this up? Like what is my major malfunction? Wait, I remember doing this. And I don't... Did I accidentally undo this? All right. What is info when I is 0? Well, there are some preamble instructions that may be output before we output these things. I could actually tweak this a different way, which we will try if this works. Like I could just set the first statement to instruction 0. Or like just prepend. I could... Step. Hey, look, we're stepping. Yay. Okay. Really what I should do is add instead of hacking this, I should add a statement debug info that's like the preamble, right? And like we did this, didn't we do a thing for dwarf where we said statement 0 is the preamble? So why did that stop happening? Where... Statement debug info dot add bytecode builder. Okay. We supposedly do this. hate typing with all this crap popping up. I feel like that's going to go off, and I don't understand why. Nope. Wait, what? Guys, I am so confused right now. I am so confused that the bones are their money, and also so are the worms. Oh wait, no, the problem, right. Okay, I keep being confused. I think we're actually fine. Okay. We can do the following thing. All right? Yeah. Okay. So what these things don't like is when they hit code at the beginning of the function that isn't in one of these ranges that we're going to output. I think this is going to work. So we're just lying about the first thing. Oh. Wait, what? Guys, whatever I took for brain juice today isn't working. I'll tell you that right now. Sean's not streaming? Did he say why? He just wants a break or what? So what's going on here? We have a thing that's after lambda offset within text section. God, dude, I fucking hate this program. I edited a comment and it won't let me debug. Like, it's trying to be so smart and it just is such a disaster. It's like, I'm trying to solve problems here. What are you doing? Let me edit a comment. Nah. Okay. Address 685-520. Why is first instruction 0? Okay. This difference is a difference between the two outputs, but it's actually okay. The deal is this, I bet you if I look at the lambda, it's an initializer. Initializers don't have this stack trace node preamble. I didn't account for that before. Lambda flags 4. Oh, it just has a bot. Wait, what? I thought we had an initializer flag. Huh. Maybe I'm wrong. Runtime support line 7? It's a C call. Well, that also doesn't have stack backing. So this code, this old code that I wrote, I'm actually going to turn off this assertion and it's going to work fine. Because it's the old code that does this funky skipping and stuff that is wrong. Although the thing about in dwarf about assuming preamble is wrong as well. We're going to have to figure that out, but this has been one of those days where we're just trying to do things that are pretty simple and run into some roadblocks. That's all. Just a little roadblock. Just a tiny little hitch in the road. Tiny issues. Hey, look, I was able to step in. That's great. Because we had some confusion about maybe whether all this was being done in the right order. Like maybe we had something keeping the executable open and we were getting a little like error cannot write executable here that I wasn't seeing. But this all looks fine and we're going to run it again and it's going to work fine. It's like the time you added a missing break to a switch and it broke everything. Yeah, I don't know. Like programming is just like this sometimes. But then what you have to do, part of getting through these is just powering through it and not quitting and taking 100 breaks. And there's also an element of being smart and doing the right thing. But yeah, like programming is just like this sometimes. Like you're trying to do something simple and it's just a slog. But now I think, well, we'll see. So now if I comment out the ye old code here, like we were trying to do, I believe that this as well will work. And we'll see. That's the wrong, let's close this. We don't want this open. Too many windows. Too many. Failed. It's calling me a failure. Oh. Because, wait. I guess I deleted that line. I mean, how can all these millennials that can't handle criticism deal with failed? Right? I mean, the compiler is telling you that you have failed. I guess maybe it's Zoomers now that can't deal with criticism, right? Or it's kind of also millennials still. I don't even know. Why am I using dwarf at all? Because I want people to be able to debug program. What is your suggestion for an alternative? Yeah, I don't like dwarf. What are you suggesting that I do instead? I would like to hear the solution. Maybe there's something I haven't thought of. Patch requests welcome. Pull requests, I mean. Make the entire universe anew. Yeah, you do that and let me know how it goes. I am making enough things anew right now and I can barely deal with it, okay? It's a lot what I'm doing right now. Okay, so we're going to check this in as our intermediate step. Actually, let's run on all the tests, even though, because we're not like interactively debugging all the tests, there might be a weirdness that we don't see, but I just want to at least make sure we don't like crash or do something stupid, you know, that kind of thing. Become Dr. Manhattan. Well, you've got to start at least as like Dr. Long Island before you can become Dr. Manhattan, you know? Or Dr. Coney Island. Like, you need to start somewhere. Dr. Staten Island. Yeah. Failed. All right. We're going to try again. We just pick ourselves up and dust ourselves off and try again. implement or changed the way instruction base addresses are computed wonderfully. And we're going right back. We're going right back. And now we're going to get this thing. Wait, did we not? Oh, it's this. It's this whole monster. I was like looking past this for the thing, and it's like, no, that's the thing. All right. So I believe the children are our future. And we don't even need to do that. Actually, we'll do that. We do need to do that, probably. The last shall be first, and the first shall be last. We're not even going to try asserting. We're just going to do this. We're just going to full Chad release build it. All right. Are you picking up what I'm laying down? All right. It's going to be amazing. It's going to work perfectly. Did I even assign the variables? I think I did. Yep. All right, let's see. Let's see what we get. Come on, load. Load, baby. Load. Load, load, load. Load. Ta-da. And step. And look. The full send functioned correctly. We should find, we need a function with like multiple nested scopes that declares variables. Here we go. Right? Because if we go there, that has a local variable that's inside a scope that we could print. All right. So we're going to not break there. That function only happens in the editor, so we'll let loading finish, and then we'll go into the editor and invoke particles. There we go. So now locals has in-group, okay? But then we'll step out, and now locals doesn't have in-group, which means that our scoping worked, bro. How good is that? All right, so now we remove, we're going to get rid of all these yucky things. We could probably even get rid of that, but one thing at a time. Let's get rid of this push pop situation. Push pop situation is the name of my new band. Getting rid of this. We're getting rid of that. Yeah, it's working because the thing that was screwing up the statement level about not going to the beginning of the lambda was either the only problem before or was the same problem as what was screwing up the scoping. So I fixed it in a different way. I fixed it by just making the address at 0 be the beginning of the lambda, right? And that way there's no gap. So that handles both of these cases and then we don't have to worry about it. Of course, now my breakpoint requires me to open the editor because it's in a different place. Int K23 is an Easter egg. Yes, it is the greatest Easter egg in the history of video games. If you can find that when you're playing the game, then you win the golden treasure. In group. Are you in the in group? Nope, you're not. Okay. So this is good. This is good. So we get rid of this. We get rid of this. We get rid of this. Now what I would like to do is go to the LLVM code and make sure that it doesn't use this push pop. Like I know that it does, and I want to try to get rid of it. Because if I can get rid of the push pop, I can delete several functions, and I can delete maybe a couple members out of some structs. It'll be great. Are there any questions about what's going on? Oh, you know what? I should run on tests. We're going to be at least slightly responsible. Any questions about what we've been doing? Go down, go down. You're just here for the Visual Studio Rages. Those do happen sometimes. Okay, the other thing I should do even before that is I should verify that dwarf sadness still works. So feel warned. I feel warned. Am I still uploading to YouTube regularly? I haven't done that in a while. Like sometimes I do that when we do a particularly focused thing that makes for good viewing, and maybe we just haven't done that in a while. Will I switch completely to debug in Remedy? Who cares what color the bike shed is? Stop caring about that kind of thing. It wastes your mental energy. Seems like it works. So that's great. So LLVM. I haven't really looked at this. I don't know if I have a theory about what to do here. So this one is like we want to just use lexical block output state so we can set debug location on pushes and pops. Now this one is weird because it drives. Oh my God. So this is the statement thing. This is the equivalent of the statement thing that we had added, that we had just deleted actually. I added this a couple of streams ago or whenever. And this is all this push pop stuff that I hate. But for LLVM, there may not be a different way to do it. In which case, I move all the push pop stuff just into frickin' LLVM. I don't know. I mean the LLVM backend, not actual LLVM. Because, I mean, it wants us to call set debug location and then do a bunch of things. Now that said, I don't know why we need to call set debug location when we enter a block. I mean, this super sucks, but it kind of looks like how the LLVM API a little bit forces you to do it, unless there's a totally different way than this. Because it wants this debug scope, right? Or, I don't know. Let's actually try to read and then regret that we even tried. I regret it already. This isn't documentation, guys. This isn't documentation, guys. I give up. I give up. For now, I'm going to at least quarantine that code into the LLVM backend. All right. So these things can go, as well as set instruction indices. These are now property of the LLVM backend. Now, that also means, though, let's just look at some of these things and make sure all the members are being used. I was looking for current block index, and there it is. That makes me very sad. Okay, this is going to go away. What is a good example of documentation done right? I don't know, anything but that. So much documentation is so much better than that. So much better. Okay. does make me a little bit sad that I can't get rid of this right now. We'll think about it later. There might be some better way to do it, and I just don't know because I'm not that into LLVM. I assume the reason it was done this way was because somebody had an LLVM example code that goes through all these machinations just to do the thing, right? Okay. Now what? I mean, we could go after some of the low-hanging fruit after working hard all day and all night. Right? Like we're 435. These timings are so inconsistent. So we're at the Bacc file. Let's try that again. I was like, oh my god, 53336. If only we can delete 3 more lines of code. So, removing push pop from x64 53336 lines, which is great. It's another decrease, not by a ton, but another decrease. Code view data size is probably the same, right? Yeah. 1921. And timing is just very inconsistent. We had 280 before, but we've been pegging higher than that the whole time, even though it's actually probably at least a little faster. 339, I don't know, dude. We've reached the realm of quantum uncertainty where waveform fluctuations, no, 30 milliseconds is not a quantum timescale. Anyway, I'll see what that measures as tomorrow when I'm at the coffee shop and off stream. WinAPI is an example of good documentation. It is tremendously better than LLVM documentation. Every LLVM instruction needs a debug location. I mean, sure. I guess. The question is something about scopes. Yeah, I mean, the deal is, I should look at what at least the parameters are. Like the third thing here was debug scope, which I guess has a lot of the location information, because this is just line number, right? It's just this third parameter is that's the pain in the butt. Like if I could just say file and line, I could do this without all this pushy poppy stuff. Pushy poppy. Pushy poppy. I could also just do it. Instead of doing this weird thing where you wait for push instruction and pop instruction index, we could actually just recursively navigate the scopes, and then just within each scope iterate over the instruction range, because we have the first and last instruction, right? So we wouldn't need this push instruction, pop instruction index anymore. That seems better to me. I don't know why it's being done this way. But hey, whatever. Whatever floats your boat. Beautiful night in Nashville. Do I find changing locations good for my productivity? I don't know if it's good for my productivity, but it's good for my personal happiness. I like moving around and being in different places and feeling like my life is not being locked in one tiny room. It just makes me feel better. Okay. Let's maybe do some low-hanging fruit stuff. Let me check this in. I think that can be done much better, but we'll leave it for now. Do we actually need... So we save a lot of stuff in this lexical block. We save the parent index, which I don't think we even need. Or do we? This is all that stuff. We could actually delete that now. I will save it. It might be good for reference for when we really do that. Okay, wait. We actually do use this. That's weird, because if you're maintaining a block stack, you would just have that on the stack. Like, actually, no, because then could also be an invasive linked list of lexical blocks. But pointers don't move. I don't know how we're going to use these lexical blocks. Like, the thing is, we're going to want to generate basic blocks later, maybe. I'm a little up in the air about that, but we sort of are going to want to generate basic blocks maybe, and maybe this will turn into basic blocks and they'll be grouped together into a lexical block. I don't even know. For now, it is what it is. All right. Okay, so let's go to the code view stuff again. And I want to look for raw add U4B kind of stuff. Oh, no, no, no. I forgot about something, guys. This is definitely something we could do, because instead of calling these, we could do an unchecked and just save out all these, right? But one of my things was what was it? Oh, this thing. Guys, in dwarf info, I kind of don't want to do Linux stuff. Okay, there are messes in the Linux stuff. We're writing, or was this in code view? Hold on. Yes, this is in code view. Okay, I think we can get our code view data size smaller. And the reason is because every time we output a reference parameter, I missed this when I was doing the conversion, but anytime this is set, which happens basically for any struct or string or anything bigger than one register, we just call add pointer type here, okay? Add pointer type literally writes a new pointer type into the file for any reference type ever, every single time. Let me just see how many this is. I want to know. I bet it's significant. Now, not all of them would be wrong. Just the first one for each type, probably. Or I don't know. That's still not quite right. But 3,217 times 12 bytes. So it's 38K. Which is only 1% right now. Is that worth it? Is that worth it? I think no right now. I think it's worth me putting a comment. But when I measured the Sokoban game, we only ended up doing this 3 to 17 times, which would be about 1% of the code view file size. At this time, not worth it yet? Question mark. See, I thought about it at least. I mean, that's true. It is 38K is, by the way, how much RAM the Commodore 64 had. So there's that. Why comments here are done with double slashes when you can use /* for multi-line comments? Well, some of us are not good enough at C++ to know that you could use /* for multi-line comments. So, you know, just you gotta give us noobs a break. That's all. We just have to eat our noob sun chips and our noob fruit and learn how to program. Yeah, the real reason is that multi-line comments run slower than the single line // comments, because these, so for example, here we have 5 // in a row. And if you're running in 4-way SIMD, then these 4 get issued because they're together without white space. These get issued in parallel, all right? And then we just have to do this one, and that just takes up 1 execution port. And it's fine, right? Whereas the big block comment, it's much chunkier. And you can't. Okay. So if we're not going to do that, I'm going to convert some things to unchecked. Wait. What is it called? I don't even remember my own things. Ensure space. I kind of feel like, so the style that I did all this backend stuff in is that I explicitly put out the bytes here. And I feel like I probably would have liked it better if I used the structs for all these and just got a pointer and filled the struct and then did the potential byte swap. Like, I might switch it all at some point over, but until then, I'll just keep doing this. All right, well, this wasn't good. It's literally... All right. I'm going to do this. I'm just doing some random stuff to make us just a hair faster that we probably won't really see in the output. Let's just even do this. So we're not like going through pointers needlessly, even though you could maybe rely on the compiler lifting that out. Oh, the modifies. That's the low-hanging fruit, guys. Okay, so let's verify that this still works. Including in debug. The modifies, that's going to be the secret sauce. Dope. Bro. That's like so 1 hour ago. Did I literally never... Let's just see. Let's see when we generate that. Oh. Right? Remember that? I said I was going to remove that. Now I'm totally randomizing everything. I'm editing so many things. So basically that assert was going off because if last is equal to first, we just didn't fill in a new length. And so it stayed at the initial value of -1. Dude, we're at 1935 now. That's Casey's game. What was the old number? Or 14 more bytes for some reason. Okay. I was just gonna do this and just make sure. I kind of want to give a talk at CPPCon or somewhere like that, where I just get up and say a bunch of nonsense, like the comment thing, and just see what percentage of the audience actually understands that it's nonsense. Or like start the lecture with things that are fake but that seem very plausible, and then interpolate over the course of the talk to something that's like obviously bananas to anyone who knows anything, right? Okay. Wait, I forgot the part where I test the breakpoint. All right. I now have a tremendous amount of vitamin boost with a lot of strawberry and raspberry electrolytes. Everyone knows that the strawberry and raspberry electrolytes are much better than the blueberry electrolytes. Like that is just... Did Mike get hate for that talk? That's what I heard. That's what I heard. In-group. Mike was not in the in-group. All right, great. Great. Probably an unmeasurable amount of speed boost there. Next. Oh yeah, the modifies. These might actually be measurable. Let's go back to building release builds. Why do we have even more code view data size? What did I do? Oh, it's a little bit icy. Compilation order is affecting it a little bit for some interesting reason. Okay. Now what? Now what? Well, that's interesting. Our 280 was a non-streaming measurement. We just got a 286 streaming. 376. 325. Oh, come on, guys. Now it's just going to be super slow no matter what. Okay, let it cool down. Cooling down. Yeah. Let's just see. Who's eating all the CPU? OBS, Task Manager. Well, everybody, I don't know. It's just a bad laptop. Anyway. If he is suggesting you should rewrite the code if the problem changes, yeah. I bet that guy thought he was real smart for finding the flaw in the argument. Yeah, like you can sort of see the text drawing in slowly, probably. At least I can see it sometimes. It's like so bananas. All right. Where are we line count now? I think we're down a little more. Nope, still 5, 3, 3, 3, 6. All right. You ready for some 7-minute abs? I want to do core hydration and have so many abs. I am so hydrated right now, everybody. Before I switch, when I had a Razer laptop still, it was pretty solid timing-wise, and it actually posted slightly better times than my desktop did, weirdly. But as soon as I switched to a ThinkPad X1 Extreme, it just became super garbage. Did I ever find a good laptop? No, I don't think there ever will be good laptops again unless I build them. There's no interest in actually making a quality product. Everyone is interested in claiming that they make a quality product while selling you the cheapest crap that they can. Even if you paid $4,000 for it, it's still them putting cheap crap in a box and charging you $4,000. You like my T490? No, I will never buy another ThinkPad. ThinkPads are done. ThinkPads are done. ThinkPads are fired. They are fired. Buy a MacBook and run Windows on it? No. First of all, they have no trackpad buttons. Second, they have giant trackpads for idiots, so I can't do it. They just kept making the trackpad bigger and bigger, and on the latest ones, it's like the size of your face. And then they ruined their keyboard, which was the only good thing about that lab. Well, the build quality as well. Thick ThinkPads are fine. I don't know. It could be one of those things where there's so many ThinkPad lines that there are competent people in charge of some of the ThinkPad lines, and for some reason they put the incompetent idiots in charge of the X1 Extreme. I don't know. I don't know. Okay. So I want to look for modifies that happen a lot. Like eventually we might want to take modify out of the code, but for now, like that happens some, that happens some. I want one that happens like for every frickin' symbol. This is still type stuff. Add UDT. Code view write compilation unit. Okay, none of those happen a huge number of times. Oh, this one. Okay, that one. Modify one, yeah. Okay. You know what? In this file, there are lots of modifies. Okay, hold on. This thing that I'm looking at is a little bit weird. What? Right? Where the hell is right relocate? Oh, it's an obj file. So right relocation, if it's Linux, we go elf. Ha ha. I started typing. I think the +1 here is 4. I never got to it. I'm a little worried about that. Question mark. Question mark. Okay. So the weird thing is with ELF files, in order for them to work on everybody's shitty broken debuggers, we actually have to put zeros in the target slot. When there are explicit add-ins. And okay. I need. So these modify functions, they step through the buckets of data to get a pointer. And we don't want to do that. And there's this complication. Linux is adding a complication. But right relocation. So we pass all these frickin' parameters now. Okay, thing one we could do is factor this into there. So that we don't have to do this frickin' thing everywhere. Although this confuses me, like, why are we doing this? Like, usually we just put the add end in there at the time so that we don't have to spend time now pulling it back into cache and whatever. But then, you know, the thing for this is we kind of want to know what the pointer is. So this is for data segment. Okay, data segment is actually an old style linear thing. So for this, it's actually fine to swap it. So these are old data segment, not new data segment, which I'm going to have to do some cleanup on at some point. So data segment data plus adder. All right. All right. $9.46. Oh, I want an arrow here. Data segment arrow data. There we go. All right. I just need to do that kind of thing a bunch of times. I'm putting an end in here because maybe we want to byte swap it. But, you know, it is what it is. Does it blend? 284, 296, whatever. Razer laptops do not have trackpad buttons and also do not seem to want to support 4K screens and also have shitty build quality repeatedly, and they will never fix it because they're trying to sell you cheap shit. Okay. So I just want to keep doing this. Those ones don't matter that much because they're not in a loop. Modify section header, doesn't matter. Apply data segment patches for lambdas. We want to do the same thing here. This one bothers me. Wait. You know, I'm not thinking clearly enough to do this. I am doing the wrong thing, guys. What I am doing right now is so wrong. It's like deeply embarrassing. Let's back this bus up. You know what? I'm going to give myself a little brain rest. I think we're going to end the stream soon while we're ahead before it gets too embarrassing. So the deal is, this modify whatever B functions modify the data that's inside one of these packed concatenator situations. However, I was replacing them with pointer stuffing, but the pointers I was stuffing were to the data that's already been packed. So it was just kind of luck that that already worked. Like maybe we didn't have any pointers that we relied on to start up the game and stuff. That was bad news bears. Yeah, I mean, I think I come at this fresh in the morning is where I'm at. Any final question, like on topic of what we've been doing? Questions? Before we head off to the land of Nye. So we had a little bit of a rough middle of the stream or beginning of the stream. We did finally do those simplifications I was trying to do, and I'm very happy about that. Very happy. This modify thing is also something I've been wanting to do for a while. It a little bit distresses how many of these there are, because I eventually want to get rid of all of them. But initially, you know, it's get rid of the loop ones. And so the thing is, what I really need to do is when I save this patch, I actually don't know. No, you know, actually, what I did might work. I need to think about it, but I mean, I could add the data segment to the concatenator as a non-copied thing. Mm, could work, could work. What I want to do when I'm fresh is, so basically, these concatenators are series of memory buckets, right? So that you don't have to copy things as you expand them and put more stuff in. Um, the uh, normally if you just add a string or add 4 bytes or whatever, it just depends on to the end. It makes a new bucket if you run out of space in the old bucket. Um, but sometimes you want to make a different concatenator somewhere else and then, spoop it in there. And that works. And that used to work by bucket copying, but then I added a steal buckets version, right? So you can take another concatenator's buckets. That works great. For the data segment, that is not a concatenator. And when I add it, I don't know if we copy it in or if we essentially do a steal like transaction. I'm not sure. If we do the steal like transaction, then what I was doing actually would work. And that might be the best thing. However, also, as you saw, there's this thing called data segment and there's this thing called new data segment. And maybe I want these to be new data segment. Right? And if they are new data segment, then maybe I should do that first. And that might just have beneficial impacts on performance of the compiler in other ways. It also might be annoying. So we have to see. But that's where I'm at on all that. All right. Nobody's really asking any questions that I can see. Last chance before we sign off into the wild. Peace. Someone has a question? What advice would you give amateur programmers who struggle to follow the stream because it's difficult? Yeah, I mean, it's difficult because sometimes I'm doing advanced things and I'm also doing them in a large program where if you yeah, I mean, I don't really know. I do not know how to help people get more out of the stream. Um, I do think it is probably hard to follow along a lot of the time. Some of that's inherent to what I'm doing, though, right? It's like I'm just working on big stuff and showing what it's like to work on big stuff. And that's just a certain way, and it's not the same as focused introductory things. Did I ever skateboard? I mean, I little kid skateboarded when I was a little kid, but I never sporty skateboarded. All right, everybody, thank you for coming by. We're not going to raid. I'm just going to go to sleep. Thanks for hanging out. We will come back and Do something. I don't know. We'll attack some. There's just, right now there's just a bunch of little things to do. I have like this list of little things. Um, which honestly, this stuff is probably more important than driving the performance numbers again. It's just that getting rid of the modifies is something I've wanted to do for a while. So I kind of want to do it, You know, we'll see. All right, thanks everybody. See you later.